My name is Karen Xin. I'm an engineer in the camera software team. Welcome to bring continuity camera support to your macOS app. To start this session, I will talk about what is continuity camera. Next, I will discuss how your application can build an automatic camera selection experience with continuity camera. And finally, I will walk through the APIs that are new in macOS 13 for continuity camera. With continuity camera, you can now use iPhone as your webcam. Setup is seamless. Just bring your iPhone close to your Mac, and it works wirelessly so you can quickly join a call. Your iPhone will appear on your Mac as an external camera and microphone under several conditions. First, you must be running macOS 13 and iOS 16. Both Mac and iPhone must be signed into the same Apple ID using two-factor authentication. For wired connection, the phone needs to be connected to Mac over USB. Or, for a wireless connection, the two devices need to be in proximity and have both Bluetooth and Wi-Fi turned on. Rather than talking through it, let me show you right away how magical continuity camera looks on devices. Here, I have a MacBook Pro and iPhone 13 Pro. Both devices are signed into the same Apple ID. The phone is placed on a stand attached to my MacBook. I'll be joining a video conferencing call with my colleague Eric today and show you how we can use continuity camera in Zoom. The app is launched using the built-in camera first, and then an onboarding dialog shows up describing what you can do with the new camera. The dialog shows up one time after your Mac is upgraded to macOS 13, when you open a camera application for the first time and there is an iPhone eligible for continuity camera. Hi, Eric.
Oh, Karen, hi.
After the onboarding dialog is shown on the system, continuity camera and microphone devices will become available in all applications. Let's switch to use this camera and see how it looks. Continuity camera uses the rear camera system on the iPhone, so you get the same great video quality that you expect from iPhone. And it works with all four orientations of the phone. The portrait orientation gives you a more zoomed-in field-of view compared to landscape orientation. Continuity camera also lets you do things that were never before possible with a webcam, including several new video effects. You are probably already familiar with center stage and portrait video effects introduced in iOS 14.5 and macOS 12.3. If not, I highly recommend watching the What's New in Camera Capture session from WWDC22 to learn more about system video effects and how to interact with them in applications. Let's go to Control Center and enable system video effects on continuity camera. Center stage keeps you in frame as you move around in the scene. Portrait blurs the background and naturally puts the focus on you. Portrait is only supported on Apple Silicon Macs, but with continuity camera, it is now available on all Intel and Apple Silicon Macs. Studio Light is a new system video effect available on macOS 13. It is supported by continuity camera when using iPhone 12 or newer. Enable this when you want to look your best on screen. It provides a stunning lighting effect that dims the background and illuminates your face. Studio Light is perfect for tough lighting situations like when you are in front of a window. Even though I'm showing you each video effect separately for a clear comparison, all of them work well together. and any combination of the effects can be applied at the same time. Here's another exciting feature I really want to show you for continuity camera. When you want to work together and share what's on your desk, you can now use Desk View. The Desk View app comes with macOS 13, can be launched right here in Control Center. It works like an overhead camera setup without needing all the complicated equipment. iPhone will split the ultra-wide camera feed in two, showing off your desk and face both at the same time, so you can collaborate on a school project or teach a friend a knitting stitch. It leverages the extended vertical field of view of our ultra-wide angle camera, applies perspective distortion correction onto cropped frames, and then rotates the frames to create this desk view. You can use the share window function available in most video conferencing apps to share this desk view feed, running in parallel with the main video camera feed. Desk View can also be used alone without streaming from the main camera at the same time. But when you do stream from both Desk View and the main camera, we recommend enabling center stage on the main camera for a better framing to capture face and body there. The feature is supported when the phone is placed in either landscape or portrait orientation. The portrait orientation provides the most versatility as there's a larger vertical field of view. There's also a Desk View Camera API to provide customized integration suitable for your application. I'll talk about the API in a moment. During a video conferencing call on your Mac, we want you to focus on the session, but we also want to make sure you are not missing anything important. When continuity camera is in use, all notifications on your phone will be silenced, and important call notifications will be forwarded on your Mac. Bye, Eric.
Bye, Karen.
We've just talked about all the great experiences available to users without writing a single line of new code in your application. But with some adoption of new APIs, you can make the continuity camera experience even more magical and polished in your app. Now that most users will get at least 2 camera devices on the Mac, we've thought more on how cameras should be managed. Prior to macOS 13, when a device is either unplugged or a better camera becomes available on the system, a manual selection step is usually required in applications. We'd like to offer customers a magical experience by switching cameras automatically in applications. We've added 2 new APIs in the AV Foundation framework to help you build this function in your app: the class properties, user preferred camera, and system preferred camera on AV capture device. User preferred camera is a read-write property. You will need to set this property whenever a user picks a camera in the application. This allows the AV capture device class to learn users' preference, store a list of cameras for each application across app launches and reboots, and use that information to suggest a camera. It also takes into account whether any camera becomes connected or disconnected. This property is key value observable and intelligently returns the best selection based on user preference. When the most recent preferred device becomes disconnected, it spontaneously changes to the next available camera in the list. Even when there's no user selection history or none of the preferred devices are connected, the property will always try to return a camera device that's ready to use and prioritize cameras that have been previously streamed. It only returns null when there's no camera available on the system. System preferred camera is a read-only property. It incorporates user preferred camera as well as a few other factors to suggest the best choice of cameras present on the system. For example, this property will return a different value than user-preferred camera when a continuity camera shows up signaling that it should be automatically chosen. The property also tracks device suspensions internally, so it prioritizes unsuspended devices over suspended ones. This is helpful for building automatic switching behavior to change to another camera if the built-in camera gets suspended from closing MacBook lid. Continuity camera signals itself to be automatically chosen when the phone is placed on the stationary stand in landscape orientation. The screen is off and either connected over USB to the Mac or within a close range of the Mac. In this scenario, the user's intention is clear that the device should be used as continuity camera. When adopting System Preferred Camera API, you should always key value observe this property and update your AV capture session's video input device accordingly to offer a magic camera selection experience. User Preferred Camera and System Preferred Camera are already adopted by first-party applications. With more and more applications adopting these APIs, we will be able to provide customers a universal and consistent method of camera selection on Apple devices. Let me show you a demo to illustrate how automatic switching with continuity camera looks like in FaceTime. Here in FaceTime, I'm in the automatic camera selection mode. For applications that want to offer both manual and automatic behavior, we recommend adding a new UI for enabling and disabling auto mode. FaceTime is currently streaming from the built-in camera. When I pick up the phone from the desk and place it on a stand behind the MacBook, FaceTime switches to stream from the continuity camera seamlessly. That is where the new class property System Preferred Camera comes in. The property value changes to continuity camera when the phone is in a position ready to stream. You might want to build your application in a similar way. Here's my recipe for how to implement automatic camera selection and manual selection mode. When automatic camera selection is on, start key value observing the System Preferred Camera property. Follow the System Preferred Camera whenever it changes by updating your session's input device. In auto mode, we highly recommend still providing options to let users pick a camera by themselves. When a different camera gets picked, set the user preferred camera to that device, which then gets reflected in System Preferred Camera property value. When automatic camera selection is off, stop key value observing the System Preferred Camera property. Instead of following System Preferred Camera, you will need to update session's input device with the user-picked camera in manual mode. But same as auto mode, you still need to set the user preferred camera property every time a user picks a different camera. So we maintain the user's history of preferred cameras and suggest the right camera when getting back to automatic camera selection mode. For best practices on how to incorporate user preferred camera and System Preferred Camera APIs, please check out the new sample app, Continuity Camera Sample. Besides bringing a magical webcam experience to the Mac, Continuity Camera also presents you with the new opportunities to harness the power of iPhone-specific camera features in your Mac app. We've added a few AV capture APIs on macOS 13 to help applications better utilize continuity camera devices. We are bringing the amazing quality of iPhone photo captures to macOS, thanks to Continuity Camera. First off, we support capturing high-resolution photos. Previously, macOS has only supported photo captures at video resolution. Starting with macOS 13, you will be able to capture up to 12-megapixel photos with a continuity camera. This can be enabled by first setting high-resolution capture enabled to true on AV Capture photo output object before starting a capture session, and then setting the high-resolution photo enable property to true on your photo settings object for each capture. In addition to capturing high-res photos, Continuity Camera supports controlling how photo quality should be prioritized against speed by first setting the maximum photo quality prioritization on the photo output object. Then, choosing the prioritization for each capture by setting photo quality prioritization property on the AV Capture photo settings object. To learn more about choosing the right prioritization for your application, please check out Capture High-Quality Photo using video formats in WWDC 2021. Another photorealistic feature is flash capture. You can now set flash mode on your photo settings object to control whether flash should be on, off, or automatically chosen based on the scene and lighting conditions. We are also making AV Capture metadata output available on macOS to allow processing timed metadata produced by a capture session. You can now stream face metadata objects and human body metadata objects from iPhone. Let's go through how to set up a session to receive face metadata objects. After setting up the session with proper video input and output, you will need to create an AV Capture metadata output and call add output to add it to the session. To receive face metadata in particular, set your object types array on the output to include the face object type. Make sure the metadata types requested are supported by checking Available Metadata Object Types property. Then, set up the delegate to receive metadata callbacks. After the session starts running, you will get callbacks with face metadata objects produced in real time. Besides AV Capture photo output and AV Capture metadata output we just talked about, Continuity Camera also supports video data output, movie file output, and AV Capture video preview layer. Here's a list of video formats supported by Continuity Camera that you want to be aware of when integrating this camera into your application. It supports three 16:9 formats from 640x480 to 1080p, and one 4:3 format, 1920x1440. You can choose between formats supporting up to 30 frames per second or 60 frames per second based on the need. Another major addition is DexView Device API. DexView Camera is exposed as a separate AV Capture device. There are two ways you can find this device. First one is by looking up AV Capture device type DexView Camera in Device Discovery session. Alternatively, if you already know the AV Capture device object of the main video camera, you can use the companion DexView Camera property on that device to access a DexView device. This API will be helpful to pair main camera and DexView device when there are multiple Continuity Camera devices around. Once you have the AV Capture device object of the desired DexView camera, you can use it with an AV Capture video data output, movie file output, or a video preview layer in the capture session, just as you can with other camera devices. DexView device currently supports one streaming format in 420v pixel format. The resolution of the format is 1920x1440, and the maximum frame rate supported is 30 fps. This is the end of the session. You learned about Continuity Camera, how to build a magical camera selection on macOS, and a handful of new APIs to integrate Continuity Camera in your Mac application. I'm excited to see you adopting all these APIs and have a great rest of WWDC.